This was the previous create wind definitions where we applied the windward loads. Just an overview of some screenshots. For the windward direction, the loads are applied, intensity. Loads are not applied, the definitions have been there. Then the leeward direction for wind X, and then for the two side walls. Then the wind is applied in Z direction. Here only the length in direction of wind and the length normal to direction of wind is interchanged. Previous was 18 and 21, now the 21 and 18. Height was mean the same. Now come in on this topic of generating wind loads for building structures. Now the wind loads will be applied. This is for the our structure. Wind definitions have been there. Just showing the parameters. And the last, the type 6. I have added two primary load cases, the dead load, and applied just a self weight. Live load have only mentioned, load items have not been added. Now there will be 4 cases I will be considering: when wind load in positive x direction, wind load in minus x, wind load in positive z, and wind load in minus z. Now we will enter our wind cases. We can create as many as load cases as per our requirement, and that depends on the engineer to case that how many load cases are required. It's his responsibility to check the definitions are proper and loads are calculated and applied. The range usually comes, which is important for applying the wind loads. Y range for first floor height. We will leave the X and Z ranges. Now we will add more load cases as mentioned, apart from the dead load and live load. First will be the wind loads in plus X, minus X. Load type I will change later to wind type. And wind in positive Z direction, and wind load in minus Z direction. So these 4 load I have added. I have left 1-2 things to correct later. Now there are 6 definitions which we have created. The types comes the 6 types wind definitions there. The select type we have got the 6 numbers. So first we will apply for the wind load in plus X, taking the windward direction. As mentioned, we have got the Y range, and here the factor is taken. Factor is used for 2 cases. One is to apply the load in each direction, and we can change the values also. This is conjunction with the surface to receive the wind load. Here the positive factor will indicate that the X force, X direction, the windward phase force will be applied with X direction. That was the primary wall which will come right in the front of the wind. This will the direction X, and windward force will be used here. And for Y range, we will take the height of wall, which is 9 meter in this case, for windward load. We will leave the open structure which is used unchecked so that all linear multiplier and loads are applied. Structure is formed by closed loops at framing members and panels at end joints. Tributary area for each node is calculated and appropriate point for forces are applied at all the nodes. So that is the effect of not checking the open structure. Once I add this, the load item has been added in our load and definition data window on right. Now I will add the wind load in -x, but before that I will have to add all the 4 wall loads for each wind load x. So I will just do it once in -x direction, then come back. So I will just close it. I have not added it. I have come in back again to wind load in +x direction. Now I will consider the second, that is the leeward x, leaving the leeward direction in x, option number 2. And now I will define the range. The x is at this wall in the back side, the leeward side is at coordinate of x equal to 18 meter. That was the minimum and maximum. I am just partially marking the wind in back, leaving the other ranges as it is. So thus now we will have to add side walls. Type number 3. I have taken wrongly -z. Later I will modify it. Added for +1 and -1. Now all the forces have been applied correctly. I will change the scales to show all the loads. The blue is the load which is currently selected from the data window. That is the +x direction for 9 meter height. And again the back wall and 2 side walls. That's the force coming from inside to out for the wind flows from x to y direction. This is the x direction wind load for, and front is the wind wall showing with the arrows. So this is correctly marked. Now I will mark when the wind load is acting in -x direction. Then the previous leeward wall will become the windward wall. And this is the side walls. I will add again the wind loads. Again taking the wind direction. This time the wind in x, I will take the -1 factor. And I will apply using the y, x and z ranges for the back wall, which in this case will be now be the windward. So x range for this back wall is 18 meter. So this is by using -1, the load will be applied in -x direction. This is the indicating all the three bays in backside with x range 18. Added it. Next I'm taking the second load, keeping factor same and using -x. And changing the x range to 0 so that load is applied to the front wall. 10.5 meter is actually the mid height. I should have taken 9 meter, but I will just mark it 10.5 meters so that the middle beam will also take some loads. Although that is we do not desire right now. This is I have taken incorrectly again. I will modify it. Wind load in -x. This should have been the Z for side walls. That is the last option I should have taken. As can be seen from the data window, when correctly for the load case number 3 I have taken correct. So this should not give in all the cases XXX. So I will again add the correct one and delete one case and edit the other one, just to showing you that this has to be very correctly applied and checked from the view loading diagram. One must check, recheck the applied loads. Look, the forces have been applied in the middle top roof, which we do not want to add for that height incorrectly I have mentioned. And another is the direction of force is in reverse direction for one case, that is the back wall. One can see from the blue diagram. That I will delete. Now from the view loading diagram, the arrows I can see the direction and forces are coming correctly. I will just close it so that correct loads are being displayed. So when wind flows in -x direction, the back wall will get force more, front wall will get less, and the side walls on both sides will get forces from inside to outside. This seems correct. Now for wind load in +z direction, I will be taking adding a new load item for it, again using from the wind load. Now the primary load case 5 is being applied. I will using the type 4 definition for Z windward direction with factor 1. Then for the leeward side I will add, and 2 times for the side walls. As this was the positive x direction, that's why I have left the z range as it is. But for side walls I need to apply the x range, which is 18 meter in this case. And y range is 9 meter for the side walls. Again applying in wind load in minus z direction, type 4. Then leeward wall, then for 2 times. When the wind will flow in z direction, we will have to take minus x and apply the ranges, that which walls, once it is for x0 and another is for the wall on the back side. This will be considered for side walls when the wind flows in that direction. I will just select it and see the signs. All the blue for the inside walls, wind will be inside to outside of the building, and for positive z direction, wind in one direction only. Forces will be on the both walls towards positive z direction, and wind will flow in minus z direction, the windward and leeward wall. So like this we have checked and discussed about the looks of the applied load. But as an engineer, you will be responsible for determining which loads are to be applied and to make sure they are applied appropriately. The pressure along each wall is applied to tributary area, then to apply the model H8 nodal point forces. Now if you consider that this is all the loads are applied to this structure, then this is here the sample has been of this model done. Anything else if need to be considered, then that additional loads will have to be applied as additionally. Say for example, if some attire or additional structure on your building structure is there, but you did not take in modeling into Staad.Pro model, so that particular item is collecting wind load, then that load items are to be added to represent that load into the model. For example, we assume some uplift forces acting on the roof joints at roof level. On that main force resisting system, the uplift forces will be applied. These have to be calculated as per the bin definition and entered here. I will add in just one load case, as in member load uniform force. There are many type of loads in the Staad.Pro. The nodal loads, member loads, uniform distributed load. I will take the member load just in one case to give that how it has to be applied. I will just take the wind load in x direction and add a member load of say uplift force, maybe 20 kg or 20 Newton per meter. That's a very small type force per meter. I will take for uplift. Uplift is usually less, so I am just assuming it like that. One can calculate from the definitions for uplift and apply that. So I will just apply 0.02 in local y direction of the member, that is the upward direction, and I will just assign it to the roof. I have not applied the more joists. Now I will add some more joists on the roof. I will divide the beams by inserting the nodes of say 3 more numbers and joining them all the nodes to form the joists on roof, so that this load is applied on the roof only. I will just model my roof joists. I must select all the top roof members, otherwise the node will take from different levels and may not apply it correctly. But I have taken the partial structure and selected that objects, so my all roof beams have been drawn. I will group them for beams types and name them a roof and apply them, so that later I can process easily and select them. So like this, all of my wind definitions and wind loads have been applied. Later one can make combination and do the analysis with different type of live loads also and get the results. So the application of wind loads have been completed. Thank you. Watch for the next session. This has been applied load. One can see the uplift is coming in upside or positive y direction. This completes the session to applying wind loads on Moen force resisting system. Thank you again.